Hello, welcome back. So today we're going to be looking at what to do with units when you do math with numbers. When I got to college, it was kind of expected that I already knew what to do with the units on my answer, but no one had ever taken the time to explain it to me. So I want to make sure that that is not the case for you guys. The rules are pretty simple. So we're looking at addition first. You probably already know what the rules are, but let's say you've got three apples and someone gives you two apples. What is the answer to this addition problem? Strangely enough, three apples plus two apples equals five apples, not apples squared. Okay? Um, if we have three apples and somebody takes away, a mean person takes away two of my apples, okay, maybe I'm happy to give my apples. What am I going to have left over is one apple. So what happens to the units on the answer when you add or subtract numbers? Well, when I add or subtract apples and apples, I get apples. So the first rule is whenever you add or subtract numbers, the units are the same as the numbers that you're adding or subtracting. The units don't change. So 3.2 meters plus 4.5 meters equals 7.7 meters. You add meters to meters, you get meters. You subtract meters from meters, you get meters. You don't get meters squared, you just get meters. So when you add or subtract, all the units have got to be the same. Okay? So what if you've got three apples and somebody gives you two oranges? You do not have five apples. Okay? You've got three apples and two oranges. Okay? What if you have three apples in your basket and somebody takes away two oranges? What do you have? Well, how did they take away two oranges? You only had three apples in your basket. What's up with that? That doesn't make any sense. Okay, so in order to add or subtract numbers, they have to have the same units. If they don't have the same units, you can't add or subtract numbers. You can write no can do or can't do, or you can just rewrite what you're adding or subtracting again. So if I take 3 meters and 2 seconds and I add that together, what do I get? Okay, I can't add those. Okay, so you can write no can do. What about 3 meters plus 2 centimeters? Can I add that? Not exactly. Okay. I can convert meters into centimeters and then add the centimeters together, and now I have 302 centimeters. And that would work, but I can't add 3 meters and 2 centimeters and get 5 meters. That doesn't make any sense. Okay, so that's it for addition and subtraction. Pretty straightforward. Multiplication and division is pretty straightforward too. If I take 3 meters and I multiply by 7 seconds, I get 21 meter seconds, meter dot seconds. If I take 16 kilometers and divide by 2 liters, I get 8 kilometers over liters, or kilometers per liter. What do I do? And it's really this straightforward. If you multiply the numbers, multiply the units. If you divide the numbers, divide the units. That's that rule. Okay, I guess this is why they expected me to know it, because it's so straightforward. But unless somebody explains it to you, you don't necessarily know it. So notice when I multiplied the 3 and the 7, I got 21. And then when I multiplied the units by putting that dot there. And notice the dot's important here because an M by an S would be a millisecond just by itself. So make sure that you include the dot if you're multiplying units that could be confused. And here I divided, all right, and I divided the units. Let's see, 7 meters times 8 meters. Well, that's 56. All right, you're not getting points for on the test for getting the right numerical answer. I'm letting you use your calculator on this. And then I'm going to multiply the meter times a meter. And when I multiply a meter times a meter, I get a meter squared. Just like if you multiply x times x, you get x squared. If I have 10 meters cubed and I divide by 5 meters, I'm going to divide the numbers and get 2. And then I'm going to have meters cubed over meters. All right, and that is going to, 1 meter is going to cancel out up top, so I'm just going to have meters squared. Just like if you had x cubed over x, you would reduce that to x squared. These are called derived units, these units that you get by multiplying or dividing other units. You're used to seeing them all over the place. Meters per second measures speed. Meters squared measures area. Miles per gallon. How did I get a mile per gallon? I took miles and I divided by gallon. That measures fuel economy. Foot pound, if you work on cars, this is used to measure torque. Okay, a few other examples here. I'm going to try to do these on my screen here for you. So we have 6 meters per second times 3. That didn't work. I'm going to try to draw these on 6 meters per second times 3 seconds. Well, this second here is going to cancel with this second down here. So we're going to have 18, right? And we're going to have meters is going to be our answer. Meters. All right, so that's the first one. That did not go that well. So here we have 6 meters per second over 3 seconds. All right. Now this is what's known as a complex fraction. I guess we already know the answer is we got 2. That's not the difficult part here. What we're going to do is we're going to take our meter per second over second, and we're gonna multiply the top and bottom by the reciprocal. I don't know if you guys remember doing this, but you multiplied the top and bottom by the reciprocal, and that got rid of what was on the bottom of the fraction. So this cancels out on bottom, and what I'm going to have left on top is 2 meters per second squared. These seconds are both on bottom, so they don't cancel out. So that one was a little bit trickier. Let's do the next one. So now here we've got 3 seconds per 6 meters per second. All right, so we're going to get 0.5, draw a little dot, second over meters per second. So what we want to do is we want to get rid of this bottom component here. So we're going to multiply by the reciprocal, the inverse. So instead of multiplying by meters per second, we're going to multiply the top and bottom by seconds per meter. That's going to be seconds per meter. So that cancels out what's on bottom. And now on top, I've got a second times a second per meter, which is going to equal 0.5 seconds squared per meter. A little bit of a trickier one there. So second squared, 0.5 seconds squared per meter. The last one, this one is pretty straightforward. You have a meter and the meters cancel. You've got 6 meters over 3 meters. You're going to get two nothings. The meters cancel, and that number would not have a unit. That's known as a dimensionless number. And that is it for math with units.